morning, students. In this session we are going to discuss about functional groups of organic molecules and its nomenclature. Organic molecules are broadly classified based on the functional groups such as hydrocarbons, oxygenated compounds, nitrogen based compounds, and thiols. Let us discuss about the hydrocarbons. Hydrocarbons normally segregate into three categories. One is alkenes, and alkynes. And the oxygenated compounds are segregated into more than 10 categories. The number one is alcohol, ethers, and this is nothing but epoxides. It's a form of cyclic ether. And the alkyl halides, aldehydes, ketones, carboxylic acid, acetic anhydrides, esters, amides, acid chlorides, and nitrogen compounds further classified into amines, and amines further classified into primary, secondary, tertiary, and nitriles. In inorganic we used to call as cyanides, whereas in organic the same cyanide group we used to call as nitriles. And imines, isocyanides, azo means nothing but the two nitrogen groups, thiol is nothing but sulfur related compounds, and finally arenes. Functional groups are broadly classified into five categories: hydrocarbons, examples are alkenes, alkenes, and alkynes; halogenated compounds, oxygenated compounds, and carboxylic acid derivatives; finally nitrogen containing compounds. Let's discuss about the hydrocarbons. As we discussed earlier, hydrocarbons classified into three types: alkanes, alkenes, alkynes, and finally the aromatic system, that is arenes. Alkanes are nothing but single bonded carbons, that is sp3 hybridized, and alkenes are nothing but double bonded carbon, that is sp2 hybridized, and alkenes are nothing but triple bonded carbon, that is sp hybridized. Normally the sp hybridized carbon is having a more electronegative character than sp2 and sp3, and moreover aromatics also sp2 hybridized, since it is also made up of a double bonded carbons. And this is nothing but the halogenated compounds, that is alkyl halides and aryl halides. Oxygenated compounds further classified into alcohols, that is aliphatic alcohols, and aromatic alcohols. Aromatic alcohols is nothing but when the OH group is directly attached to the benzene ring, that is aromatic alcohols. And ethers. In this, oxygen acts as a bridge atom, and it holding the two alkyl groups, or it may be two aryl, or sometimes alkyl and an aryl. That depends upon the nature of the alkyl chain get attached. And the next one is aldehydes, that is but it should have a terminal CHO, and ketones, and finally carboxylic acids. So the next topic is systematic IUPAC naming of organic molecules. Before naming, we have to fix the parent of the organic compounds. Parent is nothing but the lengthiest carbon chain in a system. After that, we have to end with suffix the related functional groups, and the prefix is normally the substituents or some minor functional groups. For example, if the carbon chain is made up of 3 carbon atoms, then you used to name it as propane. Suppose 8 carbon atoms, octane. In case the carbon chain is made up of double bonded system, octene, end with suffix ene. Let us have some few discussion related with the IUPAC nomenclature. The first category, here the lengthiest carbon is this one, and this methyl unit we consider as a substituent. Always the substituent has to be named first. So since it is in the second carbon, so 2-methyl butane. Similarly, it's a symmetrical hydrocarbon. Even if you're giving numbering from left to right or right to left, both are same, and the methyl unit is at the carbon 3. So 3-methyl, the number of carbon in the parent is pentane. And finally here, in the second position 1-methyl is there, and in the third position 1-methyl is there. So totally 2,3 dimethyl hexane. Hexane means 1, 2, 3, 4, 5, 6. So in the second position 1-methyl and third position 1-methyl. Let us see this example. Here the substance is methyl and ethyl. As per the nomenclature, the substance has to be named in alphabetical order. Since ethyl comes first as per the alphabetical order, so it has to be named first. And ethyl is in the carbon 3, so 3-ethyl 2-methyl, the parent chain is hexane. Let us name the halogen related compounds. Here the parent is made up of 5 carbon systems. So pentane, and the system is in the form of cyclic, so cyclopentane, and the substituents are fluorine, 2 fluorines and 1 methyl. Since the fluorine is coming as per the alphabetical order, so 1, 4 difluoro 2 methyl cyclopentane. And similarly, this one here, the substituent is ethyl, and another one is iodine. So as per the nomenclature, ethyl has to come first, so 3 ethyl 2 iodo pentane. And similarly here, 2 chloro 3 methyl butane. Here in this case, the functional group is aldehyde, so including the aldehydic carbon you have to consider as a parent chain. So the total number of carbons in the system is 10, so you have to name as decanal, and the substituent is methyl in the 7th carbon and ethyl in the 6th carbon. As per the alphabetical order, ethyl has to name first, so 6 ethyl 7 methyl decanal. Okay, here we are having some more examples. So here the parent chain is heptane and the substituent is methyl, and metal is in the carbon 4, so 4 methyl heptane. And here the parent chain is pentane and the functional group is alcohol, so pentane 1-ol, and the substituent here is propyl, so 2 propyl pentanol. Here the functional group is carboxylic acid. Including the carboxylic acid carbon you have to consider as a parent, so butanoic acid. Here the functional group is amide and the substituent is methyl, so 3 methyl butanamide. And here also the same thing, the carbon chain is made up of around 7 carbons, so heptane, and the substituents are methyl. Since all the substituents are similar, you have to give the position of that particular number. For example, 2, 2, 5 trimethyl heptane. And here you are having 2 types of functional group. In such a situation, you have to give priority to the carboxylic acid. Always the carboxylic acid prefers number 1. So you have to give numbering from here. So then the OH group will become the substituent. So 5 hydroxy 2, 2 dimethyl, including the carbon in the carboxylic acid, pentanoic acid. Again here also 2 functional group is there, carboxylic acid and ketone is there. As per the priority order, carboxylic acid has to give more preference. So 2 methyl 4 oxo xn2oic acid. When the ketone has become a substituent, you have to use the term called oxo. Similarly, minor functional group called halo, nitro, nitroso. Everything has to be follow the same nomenclature. Thank you.